Hi guys, in this video I will show you how to create this procedural spiderweb which dynamically connects to surrounding objects with Blender geometry nodes. So yeah, let's start by creating a new file. And here we want to first create some objects on which my spiderweb can connect to. So I simply duplicate the default cube for now, doesn't matter really, and place it in our scene. And we want enough cubes to connect our spiderweb to. So yeah, that looks okay, I guess. And now I want to place all these on a new collection, which I call connections. And I also want to switch my view to a matcap. And yeah, so next thing I do is I create an object on which I create my geometry nodes. And I switch this here to geometry nodes. So yeah, I create my geometry nodes. And the first thing I do is I insert some lines which I rotate around the x-axis, and then I check for each line if it hits an object, and then I want to connect the endpoint of the line to this object. So yeah, let's first create some lines, and we do this with first a mesh line. This is our points which we set to the 0 position. And in future Blender versions there is a special node for this, which I think is called points, which does exactly that. But for now we can work with the mesh line object. It's a little bit counterintuitive, but yeah, you have to think of it as like X points, which we can define here, which are placed at the 0 position. And then I instance some lines. So take the curve line and instance it here. And yeah, you can see that these lines appear, but they are overlapping. And we want to rotate these lines around the x-axis. So first combine X, Y, Z, plug it into the rotation. And we increase the rotation by the point index we've defined here. So when I take the index and plug it into X, you can see that something happens. And right now, if the index increases by 1, our rotation increases by 1 radian, which is like 57 degrees, I think. And to make it a whole rotation, we can simply take a divide math node and divide a whole rotation, which is 2 pi or tau, and we divide it with our total index amount we have. So take an integer here and plug it first in here and then in here. And then I simply multiply. So multiply math node. You can see here that this is like the strength of the rotation. And I multiply this with this. So you can here dynamically change this, and it always describes a whole rotation. So let me set this to 12 for now. And then I also want to rearrange my nodes a little bit. And I call this base threads. Okay, so now we want to check for each of these lines if it can connect to a surrounding object. So let me look if we have enough which it can connect to right now. Let's quickly place these a little bit better. Okay, and we can do this with a Raycast. And so yeah, let's create a Raycast. And we want to check our collection. So I need a collection info node. And here I choose my connection collection, set it to relative, and I also need to realize these instances. And this is our target. And for the rotation, we can simply take the rotation we have here, but this rotation is in radians, but our ray direction is a vector. So we need to convert our rotation first, and we can do this with a vector rotation node. And we want to rotate a vector which points in the same direction as our curve line we have here. So we create it by with a combine XYZ node, and also set the Z to 1. And this is our vector we want to rotate. And we want to rotate it by this rotation we have here. So I can simply change this to Euler and connect this to here, and then we have our ray direction. So I connect this to the ray direction, and let me include this in my base thread frame. And now I want to say, if our ray hits something, we want to instance a line, otherwise no line gets instanced. And you can see that something happens. And to make the endpoint connect, we can simply multiply our hit distance with the scale. And this we can do because our scale here is exactly 1. And you can see that these lines start to connect to the surrounding objects. Yeah, so that's the really simple first step. And next we realize all these instances. And I think it would be cool to have a little bit of slack, because right now all these lines are pretty straight and it looks a little bit unnatural, because in the real world we have some gravity. And so let's do this with a set position node. We want to offset it along the z-axis, so combine XYZ. And here we want to take the curve factor into account, which goes from 0 to 1 for each line, and we can access it with the spline parameter. And plug it in the z coordinate. And if we, for example, take a power node, we can create this nice curve by putting an exponent of 2 in here. And you can't see something happen. That's because our curve geometry is at the moment only 2 points, a start and an end point, and we need to create some. So we resample the curve. And also I want to change this to length. So the distribution is even for each of these points. And yeah, so yeah, you can see that something happens, but it gets displaced at the end of our curve, but we want to displace the center. We want it to get pulled down. So this is because our value here is 0 and here it is 1, and we can simply do this by subtracting 1 from the result. And to control the amount of slack, we simply choose a multiply math node, and you can see that the slack starts to appear. And this looks good so far, but there's a little problem. If we rotate our spider web, let's quickly do this and maybe create some connections here. And if I increase the slack, you can see that it is happening on the local axis, but we want it to happen on the global axis. And so we want to convert this rotation here to the world rotation. And I haven't found a really good way to do this with geometry yet. Maybe in future version there's a node for this. But for now we want to instance an object in our scene which has a neutral rotation. And this I'll do by creating an empty. And I call this neutral. And maybe I can also disable it from being selected and display it, so I don't accidentally rotate it. And here in my geometry node setup, I can reference this object with the object info node. I choose the neutral object. Then I set this to relative. And right now I simply take a vector rotate node, and I want to set the rotation of this vector we have here to the rotation of this object. And right now the slack happens as expected. Doesn't matter how we rotate this object, always gets pulled down in the z direction of the world coordinate system. So yeah, let's reset it for now and don't make it this extreme. So yeah, this is our slack. Let me put a frame around this and call this slack. Okay. So right now we have our base threads, and the next thing we do is to create these spirals. But if we observe a spider web in the real world, there is like a circle that is spanning around this whole spider web. And this is the first thing I want to create. So now it gets a little bit complicated, because my idea here is to place a line on each of these lines we have here and connect the endpoint of these lines to the previous line or to the next line. And this we can do by simply choosing a point on our lines and instance another line here, and then we can connect the endpoints of these lines. So sounds complicated, but I think we can do it. So let's create a new connection we have here. Because I want to display both, I use the join geometry node, and oh no, I want to make a new branch right here. Okay, so first we only want a single point of each curve. So first we take an instance on points node and create a line. And you can see now for each point on these baselines there's an instance, but we only want one. So my idea here is to delete every point for each line except the one we do need. So I create a delete geometry node, and here I take our spline parameter node again, and this has an index socket, and this index counts from 0 up for every curve we have. So each curve has some points and goes from 0, 1, 2, 3, 4, blah blah blah, you know. And the index output here is different from the one we have here, because this takes our whole object into account. So only the first line goes from 0 to, let's say, 20, and then the next line goes from 21 to 32, for example, and then the next line goes from 33. Yeah, you've guessed what I mean. So we need the spline parameter, not this one. And then I want to say with a compare node, if our index, so I changed this to an integer, is not equal to, let's say, 12 for now, we want to delete the geometry. And you can't see these single points, but if I look here, you see that these lines start to appear. And this describes the distance from the center or the origin of our spider web. And if I watch both together, you can see that these lines start to appear. So yeah, and maybe I make this here more accessible by creating an integer node, because I also need this value here again later. And now comes the complicated part, because we want to connect these lines. And yeah, let's do this. We are not scared of this. So we realize our instances here first, and then we want to set a position. So set position, and we only want to set the endpoint. So we can do this with the endpoint selection node, and we want to exclude the start from it. We only need the endpoint. And you can see if I change a value here, only the endpoint is affected. And yeah, so let's start. So right here we have our points, and I simply need the position of the previous or the next point. It doesn't matter, it only is a matter of the direction we want to connect our lines to. So I can do this with the field at index node, which is very useful and underrated. And I want to choose a vector, because the position is a vector, and so I take a position, and then I take the index and simply add 1 to it. So I get a position for the next point we have here in our points array. So now, right now, if I connect this here, it should connect, but there's a problem at the end, because right here, if I add 1, there is something weird happening, because there is no point. And we can solve this simply with a modulo. And for the modulo, we need the total amount of points. So modulo. And we can get the total amount of points with a domain size node. And because this is a curve geometry here, we change this to curve, connect this, and right here we have our point count. If we connect this here, it still doesn't work. That's because our point count right here is different from the point count we have after instancing our lines, and because each line consists of 2 points, I simply need to multiply our point count by 2, And now you can see that we have a nice little circle. So let's quickly organize this. And I call this connect ring. And for these I don't need a separate frame. Okay, this looks good. And with this value here we can change the size of the ring or the radius. But there's a little problem, and you can see it if the radius of our circle is bigger than the next, or the distance to our next connection object. So let me show it. And I want to make these threads disappear if the radius here is bigger than our distance. And because the radius is defined by points, we can do this pretty simple with the spline length node. And this also has a socket for the point count. And then I want to say, if the point count is less than our points here, we want to delete the curve. So quickly do this right here, because we also want to delete the geometry here. And then I take another compare node and set this to integer. And we say if the point count is less than the point count we have here, which describes our radius, we want to delete a spline. And yep, now let's hope that everything works. Yep, it works. Or it isn't, because if it is equal, it still has this little error. So I change this to less than or equal, and now it should work. Yeah. So next thing I want to do is I want to create some lines which connect our outer ring to the center. And this is pretty easy, so let's do it. Here we have our ring, and on this ring I instance some points. So instance some points, and I want to instance a line again, curve line, and right now it only gets instanced at the end and at the beginning. And so I need to resample this curve again, and I set this to length to get an even distribution. And I plug this into my joint geometry to see everything together. Make a little bit of space. Okay, so we want to set the endpoint to the center position here. So I need a set position node and an endpoint selection node again. Only want to set the end, so like this. And how do we get the center position here? That's pretty simple. We need a transfer attribute node. And I make a little reroute from over here. And I want to transfer a position, so a vector. position as an attribute, and I want to transfer it by index, so I switch this to index, and the index for the center point here is 0, so I take an integer, leave it at 0, plug it in here, and now I have the position of the center point of our spider web. And if I plug this into the position right here, you can see nothing happens. That's because I haven't realized my instances. I forget this so often. Yeah, so yeah, it works, but you still see a problem because at the endpoint of each of these lines of our ring we have here, it also instances a line we don't need because our main threads already is containing of these lines. And this is pretty simple fix. And we do this by saying here that we don't want to instance the points on the end and the start point of our base geometry. So we need another endpoint selection node. If you plug this straight in here, it only gets instanced at the end and at the start. And how do we invert this? Do this with the math boolean node or boolean math and change this to not. And right now it should work. So let me quickly rearrange these. And yeah, so works okay. Yeah, so what I like to do is to pull our outer ring a little bit to the center. So because all of these lines here creates a little bit of tension, it pulls the outer ring a little bit inwards. And you can also see this in the real world. So yeah, let's do this. But first I want to organize this a little bit. And I call this here center position. And this I call level 2 threads. Okay, so to pull the ring inward, I need a little bit of space here because I want all this to happen after our ring. And here we can see our ring. And I want to resample this to give it more geometry because right now it only has, each line only has 2 points. So resample curve node. And for even distribution, I set this to length again. And now, similar to the slack, I create a set position node again. And my idea here is to pull these points to the center based on the factor of the curve which I need to remap to have this nice little curve here. So sounds complicated, but we already have our center position here. So let's quickly push this a little bit over here. And let me visualize what I mean by taking a position. So if I plug the position straight in here, nothing happens because this is our original point position. But if I mix this position with a mix RGB node, which you can also imagine as a lerp node between two vectors, because color is a vector, we can, yeah, you can see that our ring gets pulled towards the center. If I display everything, you can see, yeah, but we only want this to happen based on a factor, so at the end and at the start of each line it shouldn't get pulled in, only in the middle. So it's pretty straightforward. We need the spline parameter again, and if I plug the factor straight into the mix, you see that something strange happens, but we can change this by remapping our value, which goes from 0 to 1 to -1 to 1, and then I take the power node again to create this nice round interpolation with a factor by 2, and if we take the exponent of 2, it always returns positive values, because yeah, that's math. So yeah, you see what happens, but right now it gets pulled only at the end and at the start and not in the middle. We want the total opposite of this, and you might guess it already, we need a subtract node. Oh, wrong order. We want to subtract it from 1, and now the middle gets pulled directly to the center, and we don't want to happen this so extreme, and we can simply put a multiply math node in here to change the strength. And yeah, you can see right now that we have this nice little tension effect. But what I don't like right now, but that's actually only my preference, is that these short lines get pulled in the exact amount as these long lines, and I want it to depend on the length of the line. So I multiply this here with the spline length. And yeah, this looks a little bit more nicer in my opinion. Okay, so let me make this a little bit more organized. Put this in a frame and call this maybe ring tension. Yeah, so let's quickly test our setup again by rotating it a little bit. And then we apply some slack over here. Everything looks good, except one thing, and this is because these straight lines here are straight, and I also want them to have a little bit of slack. So let's quickly reset everything again. And here you can see this has nice slack. Maybe it's a little bit extreme at the moment, but yeah, so and these are straight. So we create another slack for these lines we have here. And I do this by simply duplicating our setup I already have here. And I make a little bit of space. And this is our lines, which at the moment consists of only 2 points. And I want to resample it to give it more geometry. and set it again to length, and then I set the length in here, and you see that something happens, but it doesn't look really right. And that's because for our main threads we said that the offset should only happen at the start, and for these threads I want to say that the start and end point shouldn't get any displacement, only the middle should get displacement. And we can simply do this by remapping our factor like we did for the tangent. Oh, not map range -1 to 1, and that's all we have to do. So the power makes again everything positive, and with the multiply node we can change the strength, and we have to adjust it a little bit to make it consistent with the other slack we have here. And right now, if I rotate, set up again, create some connections, you can see that it kind of looks good. Yeah. But we reset everything again because there's one step we have to do, and this is creating the little spiral here in the middle. And there are multiple ways of doing this. In my test project I've created it the same way. I've created this outer ring here, but for this tutorial I guess it's a little bit confusing because the setup is kind of complicated, even more complicated than the one we already have here. And I found another way of doing this, which is pretty simple, and this is by creating a spiral curve and then projecting this spiral onto the web we already have here. So let's do this. So first thing, we create a spiral, a curved spiral, and I want to set the height to 0 and also the start radius to 0. And here I have different parameters, but for now I only want to change the rotation to maybe like this. And yeah, this might work for our base. And because our spider web at default is rotated like this, we also need to rotate our spiral around its y-axis. And I do this here with the transform node. Then I rotate it around 90 degrees. So now if we display this together, you can see that the spiral is at the wrong location, and I want to offset it to the center position. And luckily we have our center position. It's pretty far away right here. So let me make a connection and translate it. Yep, it worked. And maybe I change the radius a little bit to make it smaller. And now I only need to connect our spiral to our spider web. And I do this with a proximity node. And with the proximity node, I say that I want to connect the points of our spiral to the closest points it can find on our spider web. So I take here my spider web as the target. I switch this to points. And then I want to set the position of these points from our spiral. So set position. And I take the position of our proximity node right here. And you see that the geometry proximity node returns an error. And that is because it doesn't accept a curve as an input geometry. So we need to convert our curve here to a mesh first. So I can do this with a curve to mesh node. And voila. It works, but it doesn't look really good. And that is because my spiderweb here hasn't had a really high resolution, which I need for the geometry proximity node. I can quickly visualize this with an instance on point and a cube. So like this, and I scale this down. You can see that these are the points of my web I have here. But for the proximity to work, I need like a higher resolution. So let's quickly resample this, and this I don't need anymore. So resample the curve, and I change this to length. I forgot to turn off auto offset here. Yeah, like this. And let's decrease it to a really tiny amount like this. And there you can see that our spiral connects really nicely to our base geometry. And with this value here, you can play a little bit to give it like this imperfect look, which it is also observable in real life. And yeah, that looks good in my opinion. But the problem with this method here is that each of these spiral points get pulled to the nearest location it can find, and so it can happen that multiple points get pulled to the same location. So I need to remove these points, and sadly it can't be done on a curve, so the spiral is a curve at the moment. But we can do a little trick, which is convert it to a mesh first, then we merge, and then we convert the mesh to a curve back again. So convert the curve to mesh, and then I merge by distance, and then I convert the mesh back to a curve. And plug this in here. And now it should work all right. So let's quickly organize this again. And we call this at the bottom here our spiral. And then we test our setup again by rotate it. Yeah, it works pretty nice. So if I duplicate it, I can do pretty cool spiderwebs with it. And it's all procedural, so I can change these parameters like the radius, if here, or the rotations, or I can go back at the beginning here and I can change the amount of connections. And what else can we do? I have another idea. So in nature, often these spiderwebs are destroyed a little bit, so they are not perfect anymore. So we can randomly delete some lines of our spiral here. And let's do this quickly. So here we have our base curve, and I want to randomly delete some segments of it. So I create a delete geometry node. And I want to delete splines. Or maybe it is better to put the geometry node right after our merging here, so we can delete edges. So delete geometry node. Here we set it to edge, and we want to do this randomly. So random value, which is a Boolean with a probability. I can put this in here. And if I take a look at this, you can see that these lines disappear randomly. Let's have a look together. Yeah, it looks like this. So yeah, that's the basic setup, which is really basic. It's quite complicated, but compared to the project I initially did, it is a really simple node tree, because right here you can see that when I simply take these connections away, that the spiderweb, something like this happens. And in my complicated setup, I created some methods to prevent this from happening. But for this tutorial, I want to go overboard. I think it is complicated enough for you. I hope you can follow it. And yeah, so maybe a cool thing to do is create a node group out of this, or just to create some group inputs. But if you can follow this tutorial to the end, you can do this yourself. So yeah, have fun creating some spiderwebs, and see you next time.